Welcome to this programming tutorial of KeyDigital's 8-button IP/IR RS-232 control keypad KD-WP8 In this demo, we will program a presentation system typical of a conference room or classroom, two applications ideal for control from our 8-button keypad. We're using the latest model, KD-WP8, but programming the previous generation keypads is identical with some feature limitations in the older models. We'll use the supplied USB-A to micro cable, a PoE switch or PoE injector, and we will download the KeyDigital management software and IR database software onto our computer. Lastly, as this is an AV system programming tutorial, of course we'll go digging through some owner's manuals to find the RS-232 and IP commands of the devices in our system. The example system is typical of a presentation or conference room with a TV at the front of the room, an amplifier for volume control through speakers, and a presentation switcher from KeyDigital. The TV will be controlled via IR and the amplifier will be controlled via RS-232, both directly from the ports built in on the back of the control keypad. The presentation switch will be controlled via IP, and we've gone ahead and mapped out our IP addresses for the keypad and switch 10.0.0.242 and 241 respectively. Additionally, you really must plan your programming. What do you want to happen when you press each button? In this demo, button 1 in the top left will be a power toggle, meaning that when the user presses the button for the first time, it will send the power off commands to the display and amp, and when that same button is pressed a second time, it will send the power on commands to the display and amp. Working down the left column, buttons 3, 5, and 7 will send volume up, down, and muting to the amplifier when pressed. 7 will be another toggle button we will demonstrate. In the right column, buttons 2, 4, 6, and 8 will each send a switching command to the IP-controlled presentation switcher to select HDMI 1, 2, 3, or 4 respectively. To begin, we power the keypad by connecting it to our PoE network switch or PoE injector. Now we grab KDMS Pro software from the KeyDigital site. Go to Products, Control Systems and Software and choose KDMS Pro. Scroll down and choose the big blue Download button. Then extract the zip folder and install the software on your PC. Now we will use KDMS Pro to set the desired IP address and name to our keypad. Note that this can also be done over the network, but the keypad's default static IP address may not fall within your network scheme, so USB is suggested for this step. Open KDMS Pro and perform a USB scan. Select Yes when asked if your device is a master controller. Wait for the USB scan to complete. Now I enter a desired name of the keypad. This is especially useful for job sites with multiple keypads installed. In the network settings subsection, I enter the desired IP address and a corresponding gateway. Press the blue floppy disk save icon and wait for the unit reboot to complete. With the static IP address set and the keypad on your network, all remaining steps will be done in the keypad's web UI. Open your web browser and enter the keypad's IP address. Enter the admin password, which is 12345678 by default. And we entered the device info page where we can see the device name, conference room, as we previously applied in KDMS Pro. Now we will set up each button. KD-WP8 supports a variety of button types: normal, toggle, hold to repeat, hold to send, and buttons with events programmed on the release. We've already given an example of how buttons 1 and 7 will be set as toggle type to send the off and on commands on alternating presses. Our volume buttons will use press and hold events so the user can hold the button to ramp volume without having to press repeatedly. We will eventually add release events on buttons 2, 4, 6, and 8 to program LED status indicators to the user, but more on that later. Enter the buttons and variables submenu and give a name to button 1, Power Toggle, and select Toggle Type. With toggle buttons, you could choose red, blue, or off LED state for the first or second presses. Red for the first press and blue for the second press will correspond nicely with sending off and on commands respectively, as we will add later. Working down the left column, button 3 is volume up. Here I purposely enter an unsupported character in the name and point your attention to our helpful tooltip for formatting info. Choose Hold for Repeat as our hold event for press and hold volume ramping as previously described. Button 5 is volume down, and I set it up the same as button 3. Button 7 is our mute toggle button. Toggle type is chosen with first press red and second press with the LED off. Working down the right column, each button will be named HDMI 1, 2, 3, and 4 with blue LEDs. I'll copy and paste using right-click or Control-V to save some redundancy in naming. On to the next step, Program Events, where we add our desired IR, RS-232, IP commands, variable value sets, or LED color control to each button. Enter the Events submenu, and the UI defaults with button 1 selected, our power toggle button. On that first press of this button, we want to send the off command to the Samsung TV, but what does that IR command look like? WP8 allows you to paste hex codes from Pronto hex sheets or KeyDigital's IR database, which we will demonstrate here. Download the IR Manager on the WP8 product page under the Resources section. We also have RS-232 and IP databases available for download. Extract the zip folder. Open the IR Manager application and allow Windows to open the software. Choose Open and browse to the IR database subfolder contained in the downloaded folder. The IR code sets are organized alphabetically by brand. Go to KD_Samsung for our TV and select the Most Models code set under the television's product category. Click the Action ID header and the power commands are now at the top of the table. The IR burst data cell contains the IR command hex. Copy that data and take note of the device's IR frequency, 38,028. Paste the IR burst data into the WebUI's data cell and choose Compass IR library data type. The default IR frequency is 38,000 kHz, a matching frequency we saw in the IR Manager. The power toggle button must also control the room's amplifier on the built-in RS-232 port. But what does that RS-232 command look like? Although we have an RS-232 database available to download, for our RS and IP devices, the first place you must check is the owner's manual or control document. Here in the RS-232 control section, we see important info. The baud rate is 9600, a carriage return is required at the end of each string, and each command begins with an underscore. Reviewing the commands, there is no power off or on, so instead we will send the mute and unmute commands when turning the room off and on with our toggle button. The command I need is _SPO01AE to enable output audio mute. Copy the command and return to the WebUI to set the baud rate, paste, and add \R for carriage return. Scroll back up and select Button Action Second Press to program what happens the second time the user presses this toggle button. We've already programmed the off and mute commands on the first press, so we will now program the on and unmute commands for the second press. Once again, we copy and paste the TV-IR command from the IR database manager into the web UI, ensuring we select Compass IR data type. And we copy and paste the RS-232 command from the manual, adding a carriage return and selecting 9600 baud rate. Moving down to button 3, our volume up button. We copy the amplifier's volume up RS-232 command, which looks like underscore SPO01AVU, onto button 3's event. Remember, we selected hold for repeat on the volume buttons with the goal of press and hold volume ramping. Selecting the same as press checkbox saves time and is used when we want to send the same events we've programmed on the button press when continuing to hold the button. Button 5 is our volume down button, so it could be programmed the same as button 3, but with the volume down command underscore SPO01AVD with carriage return. Make sure you select the correct baud rate. It's easy to forget the fine details. Button 7 is our mute toggle. Once again, we program unique events on the first and second presses. The first press is the audio mute command, which goes along with a held red LED state. Select built-in RS-232, set the baud rate, find the mute command, copy, and paste into the web UI. On to the second button press, where we will unmute the amplifier, apply the needed settings, and enter the command. I've saved the right side buttons to be programmed together because they're so similar. Recall that these will simply send an IP command to our switcher to select HDMI 1, 2, 3, or 4. But again, what does that IP command look like? Well, again, the best place to learn this is to refer to the owner's manual. The protocol tells us the switcher communicates on IP port 23, commands are not case sensitive, and must not include any spaces. Also, a carriage return is required at the end of each command. I found the switching command, SPO SIYY, where YY is the input number 01, 02, 03, or 04. Return to the web UI and paste or type the command in the data cell with the carriage return added. The IP address is the address of the switcher because the keypad sends the command directly to the switcher via the network. Repeat on the remaining right column buttons. Button 4 is HDMI 2, SPO SI02. Button 6 is HDMI 3, SPO SI03. And button 8 is HDMI 4 with command SPO SI04. I click each button to review and see that the only difference is the number 01, 02, 03, or 04 in the input value of the command, and we are ready to load our program into the keypad. Go to Export Load submenu and choose Load to Keypad. Read the important caution notes and press Continue. The project loads into the keypad from the web UI via the network. We see the project loads quite fast and we receive a success message. Now we can test our programming. To test control, we would need the TV, amplifier, and switcher. But if we don't have those devices, we can still test to ensure our button LEDs are behaving correctly and review the commands sent. KD WP8 includes a useful virtual keypad, which behaves exactly like the physical keypad and also shows us a log of the events that occur with each button press. It's a nice alternative to walking to the wall, pressing the buttons, and checking each device one by one. We press button 1 to see it toggle from blue to red and see the IR command and RS-232 commands have successfully sent from the built-in ports. Press again to toggle back from red to blue and that the ON commands have been sent. You can clear the log when you wish, and I proceed to press button 3 and button 5. Volume up and volume down have been sent, and I could see all the details of the commands are correct. Now I test press and hold for button 5, and I see that the command sends multiple times until I release the button, just as programmed. Button 7 is a toggle button alternating between red LED and off LED and sends the amp's corresponding muting commands. Now I test button 2, and because I have my switcher live on the network, I see the command was sent successfully, meaning that the keypad connected successfully to my switcher and sent the command. I repeat testing the right column buttons and verifying the details of each command send. All appears to be working well. But I'd like to go the extra mile in my programming so that our keypad can also indicate to the user which of the 4 HDMI inputs is currently selected. That is, if HDMI 1 is selected, then its button should hold blue, while the other HDMI selection buttons have their LED lighting off. If HDMI 2 is selected, then its button should hold blue, while the other HDMI selection buttons have their LED lighting off, and so on. For this, we begin by adding a release event to buttons 2, 4, 6, and 8, our HDMI selection buttons. Return to Events and select the Release button action. Now you may be thinking, why does this need to be programmed on the button release? The release is the proper location for this because each time you press a button, its LED will naturally glow in its chosen color for a momentary period of time. So we add these LED latching events to the release so they can immediately take place after the user releases their finger from the button. I name the event LED2 ON and I choose LED addition event type, which controls the LED behavior for any of the 8 buttons. I choose the button I want to control, button 2, and I choose blue LED color. So when I release button 2 will hold blue. I move on, LED 4 off. LED 6 off, and LED 8 off. I name each ahead of time to remind me what each event will be. So, when I release button 2 will hold blue, while buttons 4, 6, and 8 LEDs will turn off. You'll notice that with LED addition events, the default button selection is always the button you're currently on. From here we repeat. Choose the button release action. When I release button 4 will hold blue while buttons 2, 6, and 8 LEDs will turn off. When I release button 6 will hold blue while buttons 2, 4, and 8 LEDs will turn off. And when I release button 8 will hold blue while buttons 2, 4, and 6 LEDs will turn off. I review the programming and see no obvious errors, so we can now load this updated program to the keypad. Now when I test the HDMI 1 button, I see the command send plus the LED addition events. Button 2 remains blue. Button 4 remains blue when it is released, with 2 no longer blue. Buttons 6 and 8 also work 100% as programmed. With everything working well in our virtual keypad, now is a good time to export our programming into a file we could save on our computer. Go to Export Load and press the Export Project button. Make sure you keep or allow the download if prompted, and now you have a secure backup file. The file may also be used to import into other keypads in the case that you have identical systems in other rooms or job sites. Another cool KDWP8 feature is the User Virtual Keypad. The User Virtual Keypad is just like the virtual keypad but without the technical log info. Access by typing in the keypad's IP address /user.htm into your browser's address bar and enter the default password user. Here you see the name of the keypad and a two-way interface exactly like the physical keypad. Add this to favorite web pages on your user's phone or tablet to add value and enhance their system experience. From here, all that's left is the physical installation of our keypad, beginning with the button caps. KDWP8 includes 175 transparent icons, and you may download PowerPoint file for you to make your own custom buttons or a PDF of the icon sheet if you want more of the icons we've designed. Now we can move the keypad into your wall box. Make sure it is installed right side up by confirming with the wording top printed on keypad. And with all installed, please test the buttons by pressing a few times each, ensuring that they pop back into position and are not obstructed by the Decora plate. Please be sure to review the Setup and Programming Guide for detailed information of the various programming events we did not cover in this video. And be sure to also take a look at the presentation and pre-programmed files we have for using KDWP8 to control PJ-Link projectors, a very common application for the keypad. For anything else, please visit our website, www.keydigital.com, or email us at sales@keydigital.com. We'd love to hear from you, and we look forward to working with you. Thank you for viewing.